Okay, so we were talking about inheritance, superclasses and subclasses, as a way to define shared properties and behaviors in one class and inherit those behaviors and properties in another class and then make modifications as needed. Sometimes that relationship isn't quite the right relationship, though, and that's where modules come in. So sometimes we have a different kind of relationship where we have an object that's similar to another object but has quite a different behavior that is quite unique maybe to this particular kind of object. And maybe it shares this unique behavior with some other objects, and those objects may or may not be appropriate to be subclasses of the same superclass. That could be one case. Another case might be that that the behavior, it isn't really appropriate to represent it in the superclass because a very small subset of subclasses maybe would use that particular behavior. So modules give us a way to define something at a higher level, like at the level of a superclass, but without kind of forcing it on every subclass of that superclass. So for example, if we consider swimming, there's a whole bunch of animals that swim, and there's a whole bunch of animals that don't swim. And those animals that do swim aren't necessarily closely related to each other, like a fish and a dog. It doesn't really make sense for fish to subclass dog. You know what I mean? A fish isn't enough like a dog that we would say, well, a fish is like a dog, except it has scales and lives in water and doesn't breathe oxygen. So when there isn't really a direct kind of inheritance relationship, but we have these two objects that share some properties or some behaviors, then we can implement that as a module. So we wouldn't want to have a swim method in animal because there are a lot of animals that don't swim. But we wouldn't want to define a swim method in both the dog class, subclass, and the fish subclass, and my cat swims, the cat subclass, and the alligator subclass, and all these other subclasses, right? Because then that violates the dry principle. So what we can do is we can group together these shared behaviors into something called a module, and then we can have our subclasses mix in that module. And if you're familiar with other object-oriented languages, for me, modules are like interfaces. So superclasses, we inherit from superclasses, we extend superclasses, and we implement modules is sort of the way that I think about it. And if you're not familiar with other object-oriented languages, don't worry about that analogy. Okay, it's just for those who are. Okay, so I can define a module, for example, called swimmable, and I can define a swim method in it. And so this isn't included in my animal class, but I can have a subclass of animal that includes the swimmable module. So I can do that for fish and dog, and in the case of my word cat, well, tigers like to swim. You may not know that. My cat thinks he's a tiger, and he likes to swim. So this is another way that we can put code in one place and use that same code across multiple objects. Okay, so that's the end of that. So it's not particularly complex. The syntax is pretty straightforward. What happened? Why did I just miss this? This just did not. Okay, let's try that again. All right, so here's another thing. This is important. You can only subclass from one class. And that's true in any object-oriented language that I know about. I don't know of any language where you can subclass from more than one class. So we can only inherit the properties and behaviors from a single superclass. Now we could have a chain of subclasses, but we're always going to inherit directly from one class. We can't say I have a fish and it inherits from animal and it inherits from swimmer. Can't do that. We can't subclass two classes. But we can mix in as many modules as you want. So you can include as many modules as you want. And that's also similar to the implementation. Or lost the word? Yes, thank you. That's also similar to what we see with interfaces. You can implement multiple interfaces, but you can only subclass from one class. So in this way, it kind of helps us decide what's appropriate to be in a module versus what's appropriate to be in a superclass. So we can consider behaviors that maybe are shared between different object types. So objects that don't necessarily make sense to subclass from each other. And we can also consider this. This is useful. If it's an is-a relationship, like a fish is a animal, or a dog is a animal, then it's probably appropriate for subclassing. So choose an inheritance model. But if it's a has a relationship, like a fish has the ability to swim, and a dog has the ability to swim, then it's probably more appropriate to choose a module. It's not super clear cut that way, but that's one guide that can come in handy. So you start to, just like with everything else that we're doing, you start to recognize patterns, and you just have to practice with this. You have to practice looking at problems and breaking them up into what are the objects that need to be represented in this solution for this problem, and how do those objects relate to each other? What are their properties? What are their behaviors? How do they interact with each other? So you learn how to ask those questions about a problem and how to answer those questions. And for everyone who does it, it's really confusing at first, and it's not clear, and it's a bit of a struggle. And you just have to practice doing it. And the more you practice doing it, the better you get at it. So like I mentioned on Monday, I think, we'll start after this week, at least a couple of days a week, we'll whiteboard through this process. So I'll have some kind of problem or application that we want to think about. How do we develop this? And we'll start from there. We'll look at what are the requirements for this problem. Make sure we understand the problem. And we'll look at then what are the user stories related to this problem. So what should a user of this application be able to do? Or who might the person I'm solving this problem for, what do I need to solve for them? And then from those use cases, we'll think about what are the objects that are going to be represented in this solution, and what are their behaviors, and what are their properties, and how do they interact with each other. And we'll just walk through those questions, and I'll help to guide you through it, and I'll encourage you to let me know what you're thinking, and we'll just keep practicing, okay? And then the more you practice, the better at it you'll get. All right, so we talked about this already yesterday afternoon. So if you were not here and missed this part of it, or maybe just it didn't make sense, that's okay. So we talked about yesterday how we could, there's nothing stopping us from putting all of our code into one file. You can do that for a whole application if you want to. No, you wouldn't want to though, because that becomes impossible to maintain. Absolutely impossible. Really hard to test. Really hard for anybody else to understand what it is. Really hard to work on it collaboratively. So it's a much better idea, as much as possible, to separate your work into separate files. And I'd much rather you err on the side of too much separation than on the side of too much combination. Okay? So clear examples of when we do this is when you define a class, put it in its own file. Occasionally you might have a case where you have a class with a very small definition and you might define some subclasses in the same file, but honestly my feeling about it is just put those things in separate files. I would never as an engineering manager, a team leader, developer, get upset with somebody because they created more files to separate things, okay? Other people may have different opinions, but I'd be surprised if somebody got upset about that. It's much better to have them in separate files. Do you have a question, Nathan? That's okay. That's all right. If you remember, then let me know. So classes, modules are another thing that you can put into their own files. Okay, and then we haven't really looked at it. We didn't talk about this yesterday, but it's good to create a directory structure as well. So, for example, we could have a subdirectory in our main project directory called classes, and we put all of our class files in there. When a project gets really big, you'll want more distinction even than that. So there will be classes related to this particular function of the application, classes related to this particular function, and you might have first separated by these particular parts of your application and then have a classes folder underneath there, or the other way around. Whatever feels like it makes sense to you, or if you're working on a team, you decide on that directory structure. Yes, Aiden?
That was my question.
Was it? Okay, yeah. And then if you start to look at other source code, and a great way to do that is to look at open source code stuff in GitHub because it's just out there for you to see, then you can start to recognize patterns. You can also look at style guides for big companies. They'll have some style guides that dictate the way that they like for code to be structured. There's no right way or wrong way to do it. There's not a single way to do it, even for any particular language or field or anything else, because there are so many different programmers who come from so many different backgrounds and people choose to do things all different kinds of ways, okay? So there's not a right answer here. But the main thing is that your directory structure should make sense. It should make sense to you. It should be consistent. So if you're using a particular model in your directory structure, like you create a classes folder and that's where your classes go, then don't put a class outside of the classes folder. Put all your classes in the classes folder. You know? So it should make sense and it should be consistent so that if somebody else looks at your code, it's really clear. You know, it's clear. And that's good because when somebody else has to maintain this code, or when you look back at this code a month from now or 3 months from now or 6 months from now, you don't have to spend a lot of time trying to remember what the hell you were doing. So it's just easier. It's clearer. So that's what we do here in this example. We create a swimmable file, and then we already did talk yesterday about requiring. Now look at this syntax. I would not do this. I'm not going to get into, if you're interested, look it up, the difference between require and require relative. It's a little bit more complicated than what I've explained. What I've said to you is, if it's your code, use require relative. If it comes from a third-party gem, a gem outside of your project, use require. Okay? And if you do that, you won't get yourself in trouble. All right? It is true that you can get away in some environments with using require to require something in your project directory. It'll work fine in your machine, and when you deploy it to production, maybe it'll work, and maybe it won't. Okay? And that's because require and require relative use particular path variables, and they use them in different ways. And I'm not going to talk about the details of it because I don't think it's super important to know about it, and it might just be confusing for some people. But if you're interested in it, go look up the difference between require and require relative, and you can learn about what the difference is. But if you just use require relative for your files, use require for gem files, you'll be okay. All right? So I wouldn't do this. So another thing is if you use require, I do think you have to use the /. I'm not 100% sure of that either. You have to let it know that it's a relative path and not something else. Yeah, you would have to, right?
Relative just means assume I'm in the current folder.
That's right, because otherwise if we used require, we didn't have this, it would have to assume that it's a gem, I think. And so gem requires come from a different directory structure. They're not there in your project folder, right? They get installed somewhere else on your machine, and Ruby knows where to look for those things. Or they get installed somewhere else in the environment. Ruby knows where to look for those things.
And the gems that I use for like globally for the advice in that case, so it's somewhere else in your machine. Are they installed globally, the gems?
They're not necessarily installed globally, but they're installed in a different directory structure, and I have to look it up myself to tell you 100% where it is.
I'm kind of inconvenient.
Well, it's just the way it is. It's just the way they chose to do it, and Ruby knows where to look for those things. Okay. So what you'll see me do is I'll always use require relative for anything that's part of my project. So we split classes into their own files, and we did that yesterday. Okay, so if you're not comfortable with that, if it still seems unfamiliar, then let me know, and we'll look at some more examples. But from now on, when you're doing challenges, if your challenges involve multiple classes, and a lot of times they will, then just practice this. Put your classes in separate files. You can, have a play with creating a class's subdirectory in your project, and then make sure that it makes sense to you how you refer to that class file when it's in a subdirectory. So, for example, I'll just do a quick demonstration. For example, with our dog class here. So right now I've just got everything in this Ruby folder. And so first I'm going to create a subfolder called, I'm going to call it lesson classes. And then in that subdirectory, where'd it go? There it is. In this subdirectory, I'm going to create another folder called classes. Now I'm going to move dog.rb into this classes folder, and I'm going to move what was our other one? Walk.rb into that classes folder, and I'm going to move dog walker into the lesson classes folder. Okay, so now what am I going to have to change? Yeah, so what should it be?
//
Is it // So look where dog walker is. Dog walker is in lesson classes in the top level of that directory. Then I have a subdirectory. It's at the same level as dog walker called classes.
So would you go /classes/dog, or just classes
If you
/dog?
you could just say classes /dog. You could also say // yeah, /classes/dog, and either one of those is okay. Now, what about in dog we have to do something too? Do we have to change anything here?
You could put dog / on the front of walker, but I don't.
But you don't have to. Yeah, that's right. That's right, because these two are both still in the same directory. That's right. So let's just make sure that it still works.
You did an inheritance
Oh no, dog. My brain said dog, but my fingers typed Ruby.
Dog walker.
Yes. Okay. Okay, it still works.
You don't actually have to specify the .rb when it's required.
You don't. No. You can, but you don't have to.
But have been, is there a best practice there at all?
I don't know. And probably the best practice will vary from place to place. So that's something worth looking up. But if you go work somewhere, then you'll see they'll do it one way or the other way. Yeah. My guess is the best practice would be not to use it because it's not required. Could be. And if you're requiring anything that's not a Ruby file, and I don't know that you would, then you would have to. But yeah, and I mean ultimately, if you're working on your own stuff, do whatever it is that you makes it clear and good for you.
Consistent.
Yeah, and be consistent. Be consistent. Don't do it one way sometimes and the other way another time. So this will really come into play. So it comes into play here too, because with Ruby, you know how we have all this optional syntax? Like we can optionally use parentheses and optionally use, can you optionally use semicolons in Ruby? Does it care if you use semicolons? I can't remember.
Everything has one.
Yeah.
Some areas.
Yeah, so you can optionally use syntax in Ruby. It doesn't matter which way you choose to do it, just always do it the same way. You know, always do it the same way. With JavaScript, when we get to JavaScript and we do ES6 versus ES5, like the new JavaScript, you don't have to use semicolons. You can use arrow, lambda functions, or you can use the traditional function syntax. And it doesn't matter which one you do, just be consistent. Yeah.
Is there an actual difference between inherit functions and dismantle functions in JavaScript?
It's just a syntactical difference, but ES6 isn't supported everywhere. So you have to make sure that you build in, you have to use Babel or something to make sure that your stuff's going to run everywhere. Yes. Yes. Yes, Sam.
You said the parentheses were optional.
They're optional except in some cases. If you have multiple arguments, I think you have to use parentheses if you have multiple arguments or parameters. If you don't, you don't have to. You have to use parentheses, and like in the case of the ternary, remember, when there's more than one statement in the block. But otherwise you don't, or you can.
Loops are one something like maybe replace doing in
You can replace
braces.
doing it with curly braces instead. Yeah. Yeah, so if you like to use loops with single statements in their blocks and you like to use curly braces, then always do that. And if you always prefer to use doing in, then always use doing in. All right, so are there any questions about the putting files, putting code in their own files, or putting files in particular directories and how we require that? Is that pretty clear? If you get stuck on it, just let me know. So what it looks like when we don't do that right, like say I left this how it was. Is it looks like this. It's really clear actually. So it'll say I can't load the file home admin class Ruby lesson classes dog. I can't find that. So that should tell you, oh, is that file here, or did I move it? Is it somewhere else? So I need to refer to it somewhere else. And then I would do an ls, and I'd say, nope, actually it's not in this directory. I forgot I moved it to the classes directory, and so I need to add this to the front of my require statement. Okay, let's have a look at, we'll come back to this in a second. Let's first have a look at the challenge for, is there one for inheritance? Oh, there is. Here it is. Okay, so we implement a vehicle class that accepts make and model properties when you create an object. What does that mean? How do we translate that sentence? Implement a vehicle class that accepts make and model properties when you create an object.
Create a class with the parameters, make and model.
And when you say with the parameters, where do we pass those parameters? Where? To what?
So
The initialize method is going to take two parameters, make and model. We'll have two instance variables so far, make and model, and we'll set those to the values of those parameters inside of the initialize method. Does that make sense? Implement a car class. It should inherit from vehicle. What does that mean? The car class inherits from vehicle. What does that mean?
means that it'll take the make and model from the superclass.
The superclass. It means it's a subclass. And so we're going to do something like class car less than vehicle. Yeah?
Less than or two less than?
No, one less than. One less than. And then it says implement a motorbike class that also inherits from vehicle. So what is that? What does that mean? So we'll have
it makes
yep.
it means it's another subclass.
It's another subclass of vehicle. So we'll have class motorbike less than vehicle. Yeah? And then we're going to have some methods. But first, devise, I think is what we meant there. Figure out where they should live. Where should these methods live? Refuel. And refuel takes one argument, liters. Wheelie. Where should wheelie live? Where should wind up windows live? And where should fuel level live? So let's just talk through it. Refuel. Where should so we have 3 classes now, yes?
Yeah.
Vehicle, car, and motorbike.
So
Refuel.
refuel lives in the superclass.
In vehicle.
So does fuel level.
Yes.
But wheelie lives in the motorbike subclass. Wind up windows lives in the car subclass.
Exactly. Does that make sense to everybody? Okay, so let's take some time and just have a go at this challenge on your own, and do as we talked about. Put these class definitions in separate files. Okay. We will, but let's do this just while it's still fresh in our minds. I promise you we'll finish off the dog stuff. Okay. But so all we have left to do on the dog stuff for now until next week is to change that loop so that it asks for user input. We talked about putting that in separate methods. Okay, so we'll look at that.